evaluation as to whether a system is working well from a particular perspective of every single user. What does it mean to know something? This is actually an interesting philosophical question that I spent almost 10 years working on, which ended up in the realms of AI, artificial intelligence, cognitive computing, which is burgeoning today. And I would like to argue that it's when we know a system in the way that we use the term to know a friend. So we know a friend because we've interacted with a friend for a long time. We've learned his or her characteristics, their foibles, their habits. We know when they're likely to cooperate or not cooperate. And so we are able to interact with them effectively. And in the same way, we can know a system only by using it and repeatedly using it and learning its foibles. What do we mean by the system? Well, that's where does it start and where does it end? A system, is it just this computer? Is it the computer connected to the internet? Is it this computer connected through the internet to the servers in the background? Is it all the other servers impinging on the traffic? So who is affecting my experience of the system? Where do we draw the boundaries? And then is it working? What do we mean by is it working? Is it doing what it promises to do? And who gets to judge that? And well, so good, bad, ugly, well, terrible. These are qualitative judgments that everybody makes from, again, subjective perspectives. So I think we need to think a little bit about what we mean by this question. How can we know when a system is working well? So, system. The way I design it, the way I describe a system is, because I'm a physicist, I think that there are a bunch of freedoms, a bunch of things we can change. These are the variables, these are the resources we can use, the things that we can change. We have certain freedoms to act. And then there are constraints which box us into a particular certain limits. Perhaps we can't exceed a certain speed, a certain storage capacity, whatever these limits are. So a system is always the balance between freedom to act, constraints on, or certain limits on the resources, but also limits on behavior. What a computer program is, of course, is a sequence of instructions or destructions that is executed in order to constrain the behavior of the computer to do a particular task. It can do all kinds of different things, but we constrain it to just one path through a particular space of possibilities. So it's really a bunch of freedoms and constraints. We can also think of it as a bunch of components, because it's natural to draw boundaries around pieces of the system and not just think of the whole system as a single entity. We manufacture systems in this way. We make individual pieces and connect them together. And we imagine systems in this way because it's too much work. It's too hard to conceive of the entire system in one go. So we tend to break things up into small pieces. The latest version of this, of course, you probably know, microservices is now, people are now talking about microservices. How many people have you heard about microservices? Yeah, exactly. But this is really just the latest expression of what we would call modularity in IT, which is a very old idea. And the idea of modularity is that in computer science, is that we can separate out a particular problem and solve just this one problem in a generic way, and then we commoditize the result of this solution to make components that we can buy off the shelf, and then we can assemble components off the shelf into bigger devices. So we have our resistors, transistors, and capacitors and things in this thing, in the computer, and then we make it into a computer, and we make it into a radio, and we make it into a whole bunch of different systems. So modularization seems like a great idea. But of course, we can take that too far, because if we imagine that this small component always behaves in exactly the same way in all systems, and that it's enough to just ensure that all of these components are individually working, we lose the perspective that when we put them together in strange ways, they may not behave in exactly the way that we plan them to. They may not even be kept within their tolerances and their boundaries. And that means that the system, once we put it together, may exhibit behaviors that we never planned for, that we never designed, because we never really considered the whole thing as an entity. And this makes systems complicated. This is a question of scale. Scale and perspective, again, because individual users make their own judgments, and as we scale things up and put more and more of these things together, it becomes harder and harder to predict exactly what's going to happen. And so the notion of causality, causation, cause and effect, becomes entangled. And we cannot simply say that we designed this microservice to do this and this microservice to do that, and therefore the system will do exactly as we expect. It doesn't work like that anymore. Once we connect networks of components together in complex ways, the system can have behaviors that we never planned for or imagined. So things to understand, I think, about systems are, what was it that we intended the system to do? Okay, a system begins with our intent. We design it for a particular purpose. What does it actually do? Okay, so there's the intended behavior and then there's the actual behavior. These are two quite different things we need to understand. And too seldom do we actually make that distinction, and this is why I'm giving the talk today almost. My goals might be different from your goals. So as we judge the system, we end up with different expectations and different determinations as to whether the system is working well. There's a principle in autonomy of components, really, individuality, which goes to microservices and to my own kind of promise theory, which is that when you have an independent component, an independent agent, it is the origin of its intent. So we bake into a particular component an intent, what it is supposed to do, and it sort of makes that promise. Like when you see a resistor or capacitor, it has something printed on the outside. I promise to resist 100 ohms plus or minus 5%, or I promise to hold 10 microfarads or something like this. That's a promise which is written on the outside of this component. That's what it intends to do. When we put it into a bigger context, its intent may not matter anymore. So as we scale up, intentions can often become washed out by scale, which is an important point. Now, 10 years ago, actually 2001, I think, I wrote this monolith for 2001, trying to understand how systems behave from the perspective of physics, again by observing systems, seeing what they did and trying to describe it. Not by asking how do we program them, or do they, are there better ways to program them, but simply by saying, let's just observe the animals in their natural habitat and see what the computer does at different times of day. And we made a bunch of measurements. And that led to a particular view of systems which impinged on things like queuing theory, resource consumption, again, system boundaries, planning constraints, variables, and a particular point of view. And this seemed kind of interesting, and it brought together a bunch of fields in computer science that hadn't really been closely connected. So it brought system administration close to things like queuing theory, which was popular in networking, but the networking people didn't really talk to the server people at that time. And so there were these very different worlds. So it was an attempt to bring all of those things together. But when I finished this, I discovered that there was something missing. And that was when you only look and see what systems do, what they actually do, you miss the key point, which is that when we build a system, it has a purpose. It has an intent. And so the intentional part of systems, why we build them, what they're for, the functional aspects, that was somehow missing in this picture, and so we needed to put that back in. That's when I came back to something called promise theory, where We try to discuss what promises does a system make, and how can we track that. So, how does a system work? How do we know a system is working well? What does well mean? Well, again, everyone makes their own judgment, and it's when we find it meets our expectations. And we may form our expectations from what the system promises, or we may actually have no idea what the system promises. We may not have read the documentation. We may simply start to use the system and have some prior idea of what we think the system ought to do. And then we start to measure it and monitor it, and we start complaining to the ops guys and saying, look, it's not doing what I expect. And if the ops guys were smart, they would say, do you know how do you know what to expect? Have you read the manual? Have you read the documentation? Sometimes they do that, of course. So there is often a mismatch between what we expect and what was actually offered. I love this cartoon from a very old cartoon. We have met the enemy and he is us. Sometimes we are the enemy of the system because we don't have clear expectations. We don't have a reasonable set of expectations as to what a system should actually do. Rather, our expectations are based on assumptions. They're not based upon promises that have been made by the designers of the system or by the operators of the system. They're just guesswork on the part of the user. So the agent itself is the origin, of the source of truth, if you like, about what a system is supposed to do. And that, I think, is an important point. That led me to this notion of promise theory, which added to that earlier book, if you like. I wrote a couple of books on this now, which really tries to address the subject of fitness for purpose. How do we know a system is fit for its purpose? Well, it makes a certain promise, and we should be able to check, we should be able to assess whether or not it kept its promise. But if it hasn't made a clear promise, how can we check? How can we know? We can't. We can just guess. So how do we know a system is working well? What does that mean? Well, do we mean, do I like it? Or do we mean, is it working well compared to what the manufacturer of the system, the author of the system, intended? What they promised? Is it keeping its promises? And this, I think, is a more important way, a powerful way of addressing whether or not a system is working well, that we need to think about when it comes to monitoring. And I'll come back to that in just a second. Excuse me. So fitness for purpose, desired outcome. We talk about this idea of desired end state. And I think one of the arguments that I've tried to make over the years is that systems should not simply make changes. We shouldn't think of deltas or diffs or commits as being the changes. We should think of convergence towards a desired goal, a desired end state. This notion of convergence I introduced in CF Engine for configuration management, where you, instead of typing a bunch of commands in a certain sequence or running a script, you define the state that you want to get into, and the system brings it always towards that state. And if it should wander out of that state, it can bring it back into that state. This notion of a desired end state is a promise. You can promise that the system will be in a certain state most of the time if you have a process which is designed to keep this promise over time. But if you haven't promised what it's going to do, if you've only said, well, we can do these commands, we can make these changes, how do you know what it's going to be? We have no idea what the outcome of all of these changes might be. Depends who did it, when they did it, in what order they did it. That's not good enough. If we want to be able to say specifically, is a system fit for purpose, will it do what we say, is it working well, then we need to be able to specify the desired outcome. So we think more in terms of outcomes and less in terms of changes. And this is an unusual thing. So if we go back to the question, how do we know a system is working well? We don't often ask ourselves that question. More often we ask ourselves, am I doing a good job? because we think of ourselves. You know, how can I make a difference? And what that results in is that when people collaborate in teams or work for a greater purpose, which is a systemic purpose, they don't always act in the interests of the system. They act in a selfish way, or selfish is not the right word, but a self-centric way. They think of themselves, you know, am I doing a good job? And maybe their idea of what is a good job is different from the system's idea of what is a good job. So I think that's an important distinction, which promise theory tries to get a handle on by saying, how do we understand a system as being a collection of individual things that make promises to one another? So in promise theory, we define agents as people or machines or components. We define promises as the promises that they make to one another. And they come from within the agents, not from outside. They're not forced from outside. They're not obligations from outside, but they're promises from within. And we define an assessment as somebody else's evaluation as to whether this agent has kept its promise or not. And the basics of promise theory say that an agent can only make a promise about its own behavior, because it's the only one that has the power to change its own behavior. Other agents from outside may influence the total behavior of the system, but they can't change what happens inside the component. Obliging others from outside, trying to force people to do things, trying to give orders, type commands, remote control access, R shell, SSH. This is an ineffective strategy because you may not have permission. You can try to effect change remotely, but if you don't have local, close, immediate access, that may fail. The system may not cooperate. And an agent can only assess others' promises from its own perspective, because each agent sits in its own world with its own boundaries, its own constraints, and sees the world from a particular point of view with its own calibrated scales, its own reasons for making judgments in a particular way. And this includes both people and software components. Software components, of course, are just proxies for people. So they've been programmed to have certain expectations by people. And then reliance or dependency on other agents can easily invalidate a promise. So if I say I can promise you I can promise you a pizza at 7 p.m. last night at the meetup, that might be a lie, because I may have to depend on the ability for somebody to transport the pizza through the traffic. So I can say I could make a conditional promise. Yes, I promise to deliver the pizza if the traffic is good, or if the traffic promises to, do such and such. And unless I take account of those dependencies, I cannot claim to keep a promise. So this notion, we're almost taught in computer science to build dependencies into systems, break things up into modular parts, and connect them back together. This makes very fragile systems. So we're taught to build fragile systems in IT. And this is a problem because it means that we tend to make promises that we know, or should know, that we cannot keep. So we come to the problem of faults. Is the system working well? Is it working at all? Well, the history of faults is actually quite an interesting story, because this goes back to, it has a long history in Norway. It's a couple of famous statisticians from Norway, from the math department at the university here, developed the theory of system reliability. And the idea is you look at components and you think that these components are mass manufactured, and there's a certain probability that a light bulb will fail at a certain time, and you can measure statistical properties, the likelihood that a light bulb will fail in a certain time. And then you can put them together into a big system and compute the effect that this may have on the total system. And this is a well-defined mathematical procedure. But it's based entirely on the idea that it's either working or it's not. from a component point of view. What it doesn't take into account is a modern software perspective where different components have different functions and the relationships they have between the different functions. You couldn't model, for instance, the idea that a certain person doesn't have permission to access another component. So the semantics of system design are missing from this classical picture of system reliability theory. So I wanted to try and put that back through this promise theory that I'm talking about and the project that I showed you at the beginning. And I tried to work on this and ask, what does this mean for us? Can we even define what we mean by errors, faults, failures, and so on? And there's a whole movement talking about the resilience of systems that likes to argue that actually we can't always talk about what it means to have an error. People often blame humans. It's a cheap trick, right? A plane crash or some major disaster, and so it was human error, which is kind of a cheap shot because it's always human error. I mean, you can always, in any chain of causation, you can always trace back something to a person eventually. So you can always point a finger at somebody if you want to, but that may not be really the relevant thing that made the problem occur. So that's kind of a cheap shot, an easy cop-out. But if we can define the notion of errors and faults and failures more clearly, as I tried to do in this project, then we have a hope of being able to address the question more objectively, more reliably. And I made these definitions. I don't want to read them out to you, but you can look at them later on, or you can read about them in the document. And I think by making these clear definitions, we can make progress. But there's something, again, going back to dependencies, there's something that all of these definitions rely on, and that is there are two aspects to systems. There are the semantics that I talked about, the purpose, the intent, what we mean for the system to do. And there is also the dynamics of the system. What is it capable of performing? Its performance boundaries, its capabilities within a system. Is it even capable of doing what we've asked of it? When we come to scaling, elastic scaling or manual scaling, which turns into queues, which turns into thrashing, which turns into all kinds of detrimental effects to system performance, these are dynamical effects. And the key lesson that I learned from the last 20 years, which I've been writing about, is that these dynamical effects limit everything that happens in the system. Everything is built on what the system can perform dynamically. If it can't perform, then it can't have the semantics we want, which represent our business proposition, our business purpose. So semantics always ride on top of dynamics. Dynamics come first. Can a system keep its promises and still be unpredictable? So can we have described a system to keep all of its promises and still not work? Sure. This is what happens when we connect things together in unknown ways. We can't always predict exactly how components, once put together, will behave. So this is a really important point. We can't simply design systems in UML or some nice planning language, some nice architectural language, and hope that the system will do exactly as we expect. It simply won't. The idea of knowledge itself, I think, I often say knowledge is the challenge of the next decade, but I've been saying that for a decade already, so maybe more than that. How do we even know what a system will do? Well, back in the beginning, I tried to ask this question by measuring systems. Back in the 90s, we just measured systems to see what they did. And we found that they often have very predictable and regular behaviors. This is just traffic from Samba, I think, Samba traffic, server traffic. And you'll see these peaks, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, not much going on. And this kind of trace has since been measured many times and reproduced by many people in many different places. It shows that our computer systems are driven by the most part, by what we do as users, our working week. This is our working week. And the peaks are around lunchtime, and the troughs are around the time when we're sleeping. This is a typical pattern. We can learn these patterns only by repeatedly visiting the system again and again and looking and knowing it like a friend. Remember this expression, to know the system like a friend. But this is what we usually do. We just throw up some sort of random variable like a CPU or bits per second on a simple time series graph, and we look at the current level right now. And we say, okay, we've got this sensory input. What does this mean? This has no relation whatsoever to the purpose of the system. You have no information in this picture telling you whether your system is working well. You simply have some, it's like taking your pulse and saying, am I doing a good job at giving this talk? These things are not really correlated very strongly. I mean, if it stops, we know there's going to be a problem. Well, it might not be a problem for you. That's a subjective, we've already established that's subjective. But this is the state of monitoring today. This is the state of the art of monitoring. It's rubbish. It's rubbish. What we can do, in fact, is what is now happening in artificial intelligence or cognitive computing, and this is actually, I worked on this back in 2000 for CF Engine. We had machine learning patterns of behavior over time, and then combining this long-term memory of learning patterns with what's happening right now, an immediate sort of assessment of what's happening right now, and using those two things together to make decisions about, do we need to adapt system behavior to take into account anomalies, irregularities in the behavior of the system. And this was tried. I won't say it had much success because I think it was too early for people to really think that this was a good idea. But now that we're really getting back into the swing of AI, I think this could well come back. There's this sort of knowledge ladder that we have for systems, again, trying to know the system like a friend. We start out fiddling around trying to figure out how to do stuff, and then eventually as we get better, we figure out what we can do to make a system. And then often it's only then that we figure out why we're trying to do it. You know, we tend to start with putting stuff together, which is why we have these bad habits about not properly defining the promises that a system should make. Because we start out by trying to see what can we do? What can we even do? And until we can answer that, we can't say, what can we use it for? But if we continue to climb this ladder, there is a point at which we end up with goals, which can be promises, clear promises. I like to use this picture to illustrate the transition from experimenting to utility or commoditization, which sort of reflects what's happening in our data centers. When we think of agriculture, we start out, you know, hunter-gatherers picking berries in the forest. They're pulling things off trees where they can find them. And this is hard work, so eventually we find tools and technologies to help us, and we can make tools to extend this manual process. But then once we've made the automation, we realize that actually making the automation work like a human would work is inefficient. Maybe there's a way to redesign the system to keep the same promise more efficiently without having to copy what a human would do with a body. And then we can depersonalize the whole thing when we know what we want to produce with this kind of hydroponics style, completely dehumanized environment, but it's much more efficient. By totally rethinking and taking the human actor out of the loop. This looks pretty much like a data center, and there's a good reason for that. It's because we try to take out the humans and use space and time to stack things efficiently. So how do we know our systems are working well? We have a bunch of questions we can ask now. Is the system keeping its promises? Is it going to fail because of scale or unexpected consequences, how can we begin to measure it? What kinds of things should we begin to measure? How can we learn if it's going to keep its expected behaviors? So I will leave you to the picture of the book that I mentioned at the beginning, which explains some of these points. And I hope that some of these points will give you food for thought for the rest of the day, and perhaps maybe even longer than that. So with that, I'll wish you a very good conference, and thank you very much. Cheers.
Okay. Jeg Jon Arild Tørresdal. That's me. For those who are or don't speak Norwegian, I'm just John, because the other ones are impossible for you to pronounce. I'm working for a consultant company called Miles in Bergen. But before that, I used to work for an insurance company in Bergen called Frende Forsikring. And my story is basically from those 6 years where I worked there, where we transformed that company into a different way of working inside of IT, so to speak. But first of all, why this DevOps thing? This is a quote that says, "The gap between Dev and Ops will in most organizations result in a major bottleneck, bringing with it significant hidden cost way outside of IT." Do you agree with that? Do you know who said that? No? I did just now. So I couldn't find a quote saying exactly what I was experiencing or actually thinking about and expressing. So I just created a quote. Feel free to use it whenever you want. So what are these costs? Well, release planning and management, handoffs, queuing time, right? Handing stuff off to other people, manual labor and coordination to get applications into production, frustrating long delivery times, and both for features, bug fixes, so forth, right? Added risk of releasing too many changes at once. That's probably the most important one of these. But very often, it falls back to this, for me at least. If it's painful, do it more often. Just increase the frequencies, make the painful things really, really painful, really, really often, so you're forced to solve it, automate it, fix it, right? Like your SSL certificates that expires every second year. You started with 2 certificates, now you have 200, while they more or less expire every week, right? Well, let this SSL certificate have an expiration date of 1 week. That fixes your problem. So what are some of the gains around DevOps? And before I go into this, I just want to explain a little bit about my background. So first of all, originally I was a developer, but I was a developer very interested in the operations side. So that's always triggered me. I always worked with server stuff and networking and that kind of things. Which kind of, when I was working for organizations, typically smaller organizations, I had my hands everywhere, within networking, within programming, everywhere, right? And that was what gave me the kick, so to speak. So when I came into Frende, I saw all these inefficiencies in the way things were being done, and I started to look at some things and work with that. So what I'm trying to say is that it's really helpful for devs to know ops, right? So if you don't think that's interesting, there's a huge future for you if you take interest in an ops. And the other way around as well, if you're an ops guy, there's a huge future for you if you start to take a more interest in development. All right, gains of DevOps. Freeing time for highly educated and paid employees to focus on continuous improvement, right? So we're smart people, right? We don't want to do repetitive work. That's the idea behind it. And of course, that common competence between dev and ops usually result in better efficiency and innovation. Faster time to market, you always need to have that on your slides. And fast feedback loops from users allowing quick adjustments. And that is one of the things that I like, is think about things in iterations in feedback loops. And you need, if you create something and then is about to put it out there somewhere where you want to have feedback as soon as possible if it's the right thing or not. So back to the company I used to work for. This is about, I quit the company for about almost 2 years ago. And I worked there for 6 years. So this is basically the story from that company for those 6 years. So have that back in your mind, is that these things also took more or less 6 years, right, to get to that point in time. So we kind of have these, what we call the reforms, or the lack of a better word. So if we look at the ops side of things, how was it before? Well, it was an external IT organization. Ops was bought, so to speak, hired. There was no access to servers in production. That's pretty common many places. There was no load balancing during deployment. You'll see why I bring that up as a particular point. Everything was virtualized except from database servers. Changes and deployments was executed by the hosting provider, so you get a handoff stuff to the hosting provider or the operation side. There were basically no monitoring. We were really lucky if we were alerted about a disk being full or something like that. Usually we figure it out by reading the error messages in the different applications we were creating. Now, actually now is like 1.5 years ago, there's a new IT operations company, but still external. There's a clear separation between dev and ops responsibilities. And this is, so when I work with customers today, there's always this hard thing where you need to figure out what's dev's responsibility and what's ops responsibility when devs are taking more responsibility inside of ops. And for me and for the companies I work for, that's usually that the operations side take responsibility for the infrastructure networking and those kind of things, the servers, the virtualisms around the servers and all that. And the devs takes responsibility for their applications, what they've created, what they know how to host most efficiently. I'm not saying that's the answer all over. I'm saying we've had really good experience with that separation. Dev has full access to all environments, including production. There are no changes allowed on any servers, meaning changes are as infrastructure as code, meaning you're using Chef, Puppet, Conda, some kind of tool to do that, scripts, whatever. Just don't go into servers and make changes directly. Everything is virtualized now, including databases. There's a sticky load balancing to ensure optimum scaling of the deployment. And remember, we're not talking about sticky load balancing as in scaling the application. You want probably to have your applications work in a round-robin type of scenario, but sticky in a deployment sense is to optimize so that when you deploy, you only take one server out of the cluster at a time and stuff like that. So you don't want to bring half your stack down just to do a deployment. Monitoring in production by dev. So the responsibility for monitoring the applications in production is a dev responsibility. And when you do that, interesting things start to happen. Like monitoring tools start popping up. Stuff we never had before, because suddenly devs have this need of seeing stuff that they didn't see before, and they never figured that they might give these tools to the ops guys. But now when they're in this, have this need, they create it. And a hosting provider or the operations side more or less just provides the bare OS. Bootstrapping and configuration of servers and deployment is fully automated. So that's on the ops side. On the development side, so this is a Windows.NET shop, right? And if you think that doing these things in Linux is hard or Unix is hard, try doing it in Windows, right? That's a completely different problem. But Team Foundation Server, which is a Microsoft product, was used for source control and build stuff. There was some unit testing, but not structured. There were typically code freezes before each release, and database schema changes was generating by diffing test to production. Sounded like a great idea at the time, right? A lot of bug tracking. Today, however, well, there's some other products used for build, not really important. Git for source control, so they moved on to something better. But unit tests and integrations tests are used when needed. And this organization came from like doing next to no automated testing to do extremely automated testing. Everything had a test harness in some way. And the pendulum went like this, and then it normalized somewhere in the middle, and they learned to make decisions for when they want to do certain type of tests or automated tests for the systems. What they discovered is that a high degree of automated tests also has a great cost, so you need to balance this. There's never any code freeze or anything like that. There's extreme focus on low complexity and microservices and that kind of thing. But that was kind of an architecture that evolved with this whole process at the same time. Yeah, every push to Git basically could end up in production at any time, and that does something with a developer's mind. And you might think that, oh, those devs doesn't push very often to Git, do they? Actually, the complete opposite. They push like 1 and 2 lines of code into production to make sure that they're in full control of this tiny bit that's going to production. And the nice thing about that is if something goes wrong in production, the error is like in one of these 3 lines of code or whatever. It's really easy to find, it's really easy to fix, and it's really easy to move forward. And then something probably some of you want to talk to me about later, no branching at all. And I'm talking long-lived branches, right? Long-lived meaning a day or more, right? Because when you start to do these iterations this fast, branches get in your way. Actually, they're always in your way. You just don't notice because you're not moving fast enough, right? And there's little or no bug tracking, which is also an interesting topic, is that how can't you do bug tracking? Well, it's really simple, actually. Just solve your bugs when you find them straight away. Because it's a bug on a feature that has had a higher priority to begin with than whatever you're working on now, right? So either you say, this is a bug, I'm going to fix it, or you say, no, it's not a bug, and you throw it away. All right, as for deployment, typically you create these packages that were handed off to the operations side, And they did this about once a month or something like that. And typically they did rollbacks once a month because there were errors, and they spent some time to actually getting this release out every month, right? Typically early morning, late night in order to get this out, so you don't get in the way of the customers. We were lucky that there wasn't any 24/7 type of requirement here, or actually there was, but no one noticed at the time. All deployments are now today automated. That's the easy part. That's the processing around this. That's the hard part. You can deploy it anytime without any downtime, right? Actually, they prefer to deploy new stuff into production in prime time. When there's the highest peak of the system, that's the time you want to do your deployments, because that's when you find out if something goes wrong. And this might sound hazardous or something, but actually there are some things that you just can't figure out or test, no matter how much you test, and you won't see the real effect until you get it out there. And if you can really fix any errors really, really fast and redeploy, this is a good way of going about it. And it might sound like, oh, you like introduced tons of errors all the time, right? No, we didn't. Because there were all kind of other things that prevented us from doing that, but yeah. Multiple deployments to production every day. The concept of a deployment pipeline, and we'll talk a little bit about that soon, but that more or less ensures that everything goes through a process and are quality tested. A lot of use of canary releasing, meaning you can like give certain set of customers access to certain functionality before others, or get your internal company people access to some stuff before the customers and stuff like that. When it comes to like technical stuff like schema changes to databases, I don't know how many years and waste we've spent on trying to solve that, but in my opinion, there's only one solution. You need to be backward compatible and forward compatible. That's it. It's as easy and as difficult as that. So no rollbacks, forward only. Fix the error and then redeploy. So basically this company has continuous deployment in test and pre-production environments, and they have continuous delivery in production, meaning everything is automated in dev and test and pre-prod, but somebody clicks a button in order to take it out to production. And of course, since it's all automated, there's also full audit of everything that happens, right? So we can track who did what and who triggered which release and what code was related to that release and so forth. So process-wise, this company was in rapid growth, right? It was not a startup. We're talking an insurance company here. I'm not sure we can categorize them into a startup. But they were in rapid growth. They had this Scrum-like process, really Scrum-like process. Business typically expected something to be released on a fixed date, right? There were long feedback loops, so what they kind of ordered and what they saw was like this huge step in time. And typically, they manually tested their entire application suite before every release, because they had to be sure that everything worked, right? That's, of course, because you change so much, you have to retest everything. So today, it's a company with high cost focus. So in insurance, this is typically referred to as combined ratio. So that is something that they have really high focus on. There's a Kanban lean type of process, so we kind of moved, we did Scrum for quite some time really, really well, and moved on from that to something else. I'm not saying that's right for you, but that was what we found was effective for us. But the most important thing here is the lean part, because basically the lean concepts and ways of thinking and theory constraints and all that is integrated into all these ideas and ways of thinking that we've used here. Yeah. So, and stakeholders, upper management, participate in daily stand-ups. And it's this story from one of the CEOs of the company who went past a group who were having a stand-up, and there's this Kanban board on the wall with some notes here, there, and it's like, wow, this line of notes on some column, right? And he has this lean background, so he walks by this office and stops back and like, what's that? Oh, that's waiting for test. Okay, so why it's not being tested, right? You have a huge bottleneck here, and in order to solve whatever you're doing here, you just need to fix that. And it's going to move a lot faster. And when the CEO says that, things became a lot easier. But of course, we also started talking about these lean concepts, and things are starting to, people are started to understand these things in different ways, or better ways, and it all become a lot easier. So, but even more importantly, they're now aware, the whole company is aware of the increased risk with infrequent releases. People are getting, like on the business side, getting really uneasy if there's like more than a week since we've released this application or something, right? They are aware of the risk of putting too much into production at the same time. And they actively use canary releasing, which I mentioned earlier. And they're continuously involved in the process to give you feedback and ensure these feedback loops are flowing, so you can get whatever you want to get out into the customer hands. Right? So as part of this process, and I'm going to take this really quick, and we can talk about this later for those who are interested, but we more or less established 9 technical, if you want, or semi-technical principles around doing DevOps in this company. The first one was the deployment pipeline. So who has not heard about what a deployment pipeline is? Right, next one. So this is just an example from Team City where we've created a deployment pipeline. But that basically ensures that whatever you create gets quality checked across a pipeline, and hopefully it's a good thing that comes out in the other end. But then we have this concept about deploy versus release. And I think that many talk about those things as the same thing. However, you can deploy to production without releasing functionality to users. So basically, continuous deployment, you can do that without releasing anything, right? And that's a powerful concept, because you can basically continuously integrate things into production without touching the functionality of the users. And of course, the technique you use to that is typically feature toggles. So, and that's also the replacements of doing branches is doing feature toggling, right? So we've talked for many years about the bad things about branching, but no one really came up with a good replacement for it. Well, I'm not saying this is a replacement, but this is a tool in your toolbox that you can use, and sometimes it's instead of branches. So, and brings me to the fourth point, which is no branching. And just to say a few things about that. So when you branch, you basically opt out of continuous integration, right? Because what do you do, right? You don't integrate stuff anymore, right? You separate things into different lines, different branches, and you move like this. You don't integrate, you move like this, right? So at the time when you actually do a merge, that's when you integrate. And people say, well, I have my own CI stuff running for this branch. I have my own environment for this branch. Yeah, well, you're still not integrating, right? You have this environment over here, which is separate from anything else. You need to continuously integrate, right? Think about continuous integration as this thing, not as a server, right? Because developers typically think about CI as a server. So, of course, the obvious thing, no branch, no merge. But the alternative to branching is, as I said, feature toggles. But if you still insist on branching, note the following. You get reduced delivery capacity, you get reduced quality, increased risk of errors, and added complexity. And of course, that's just something I say, right? You don't take my word for it. But that's our experience, right? But you don't see this until you start to increase the frequency of your feedback loops and the way you release and these things. Then these things are really starting to hurting you, and branches become one of those painful things. So the other one is no manual changes on servers, which I've talked briefly about. And there was something from Microsoft that said something about that, ironically. Whenever there's a new project or a new thing or an application or whatever you do, this company deploys Hello World to production. That's the first thing they do. They make sure that their deployment pipeline is fully functional, and then they start their development, right? And they continuously deliver things into production, but they don't release it, right? Because the users don't have access to it. Well, maybe they give access to some users, but they continuously put it out there from day one, right? Yeah, version control of infrastructure, the 7th point, that's what you get when you do infrastructure in code, basically. That's kind of an added benefit, as long as you remember to check it into your source control system, which would be stupid not to do. Canary releasing, well, we just talked about that. Netflix was one of the first to coin that. And then we have this discussion around done, right? How many of you guys have been sitting in meetings for, I don't know how many days of your life discussing the definition of done, right? So the thing is, done is in production. It's not done or done or whatever you come up with, right? Done is in production. And there's always this wise guy who says, well, is done in production or is it deployed? Well, I leave that up to you, if it's deployed or released, right? That kind of definition. But the point is that when you have this process where you quickly can get things out there, the definition of done gets really a lot easier to handle. So basically, a summary of the 9 principles. There are some improvement points with this organization, of course. Since they're on a Windows platform, the container adoption kind of takes its time. There's smoke testing, performance testing, and so forth. But if you want to know a lot more about this, and basically what we use, that's the Bible, in the lack of a better word, was this book. So I expect a lot of you have already read it, but if you haven't, you should really do it. So that was a 1-hour presentation in 30 minutes. Thank you.
bare legge den. Kan vi legge den? Ja, jeg går opp og så gir jeg den til det. Ja, det er henne, så hun kan få den her. Du trenger ikke noe å bruke den, eller? Jeg bruker den. Okay, hello. Yep. Please find your seat. Everybody hear me? Before we start with the next talk, we're having a word from our sponsors. They've got have a 1-minute pitch. We'll have 3 now, and we'll have the other sponsors after breaks later. And I only have 2 things I would like to say. Is that first, the conference is being streamed. All the talks is being streamed to the internet, and I know that all the speakers didn't know that, but now you know. And the second thing is that there was some noise in the back during the last session, so please keep your voice down out there. Yeah, are the sponsors ready? There's only one here. There's 2. I think the last one is Atlassian. There you are. Okay, so can't remember which one we were starting with, but I think it's the first one. So please.
Thank you. My name is Ole Bakstad, and I work for Knowit. We're a Norwegian or Nordic consultancy firm with about 1,800 employees. We've been working with DevOps since 2008 at one of our customers in at the city of Oslo. But we're also working hard to transform all of our customers to this new DevOps thing. We're so much slow. If you're interested in working on hard problems, either in an already existing DevOps environment, or you're interested in transforming legacy systems to this new way of life, please come talk to us. We're interested in hearing what you think. And if you want to look at our job descriptions, you can look at devops.knowit.no. Thank you.
Hello, I'm Mike. I work for Pragma. We are a continuous delivery and DevOps consulting. Actually, we are a continuous delivery company. We say DevOps too, but it's all the same for us. With apologies. So we help companies improve their processes and tools and practices. We've been doing this. This is all we do. We are partners with Atlassian, with GitHub, with Docker. So we've got all the best stickers. Come to our booth and get some stickers. Thank you.
Good morning, everybody. I'm Jan from Atlassian, here together with our partner, Pragma. Just show hands, who doesn't know who we are, Atlassian? See, just one. Well, I encourage you all to come to our booth later on if you want one of these fabulous t-shirts, or if you want to win a drone, or just want to have a quick chat on what we do, how we do it, and how we can help you together with Pragma. So enjoy the conference, and hope to speak to all of you at our booth. Thanks.
Thank you. So our next speaker is Daniela. So please enter the stage. And a warm welcome to Daniela.
Okay. Fix this on here. Yeah. Okay. Now you see my password, but it's actually or not. Okay, so my name is Daniela. I come from Syntaf. So it was very good to see that there is a balance here between research and practice. And we try to bring a little bit of our perspective on practice that we see from the perspective of the researchers. So my name is Daniela. I work together with 2 other researchers from Brazil. And some of you in this room were interviewed by us, and that's where we take our responses from and what we are going to talk about it today. So it's about communication in DevOps, and then I'm going to tell a little bit of like why we started looking at this and what we found. So the agenda is going to be first, when we started talking with different people that are also in this room, everyone had their different perspective on DevOps. So then we are talking with Jan, and he said like, okay, can you bring what you found about what are the different perspectives? And this is what we are going to show a little bit. And then we always saw that like people always say like, you know, communication is a problem. But what is this thing of communication? Everyone always see like communication as a black box, but then what we are trying to do in our research is to open this box of communication and try to understand a little bit like what does it mean and how to make it better and more effective for teams. Our work is mostly on teamwork, and we work a lot with agile teams and other types of teams. But that is mostly what we work at in our group at Syntaf. And then some lessons learned. So then what is our research about? We were thinking of like, how can two-way communication happen effectively in DevOps teams? So that was the main thing that we were concerned about. We started asking people, in this community was one that was very helpful for us, and also in Brazil, because the student I work with, she's also in Brazil, and she works in one of the companies that are sponsoring here. And then like we started interviewing people. We interviewed 20 people, healthware developers and healthware operations. So then we have kind of a balanced view of like how communication can be better done and more effective. So then the first question we had was like, what's DevOps for you? You know? So then who here thinks that is about cultural shift? Okay. Who here thinks that is about tools? Okay. And who thinks that is about collaboration? Okay. And who agrees with Patrick Debois? Okay. That was little. I thought it was going to be much more. So he sees that as a global company collaboration. So that is like his view of DevOps. And then actually what we found out and what we are discussing is that it's, and then I have to ask like, who thinks that is all above? It's everything else. Okay. So the view that we have is that like, actually, DevOps is not only about tools, it's not only about collaboration, it's not only about the culture, but it's about many different aspects that you can have in the collaboration or in the development as a DevOps team. So it's about collaboration between team members, it's about infrastructure as a code, and it's about automation of the tasks, processes, and workflows, and it's about monitoring. So all these aspects you have to take in consideration when you are doing DevOps. So everyone is right, but at the same time, you cannot have just one-sided view of what the word DevOps means and what the whole thing, the whole process means. So that is where we started looking. So then the point that we started looking a bit more closer is the collaboration part. And for the collaboration to be effective, the communication has to be effective. So we come from the hypothesis that conflicts happens because there are ineffective communication happening on the teams. So then misunderstanding starts to happen, incorrect strategies and mutual feelings of frustration starts to happen. So that is why we started thinking like, okay, we have to start studying a little bit how communication can be better, you know, and how we put DevOps, devs, and ops to work together. And that is how we started with this. So my theory background, then we started taking a look of like, is there any theory that already can explain a little bit of like how can we do this better? And one of the theories that we found was in channel communications. And then we thought that it helped quite a lot to start seeing some of the aspects that we need to think in communication so then the effectiveness comes. And then there are 7 main points They are about the conditions of the environment. Like, for example, if you are co-located or not, then this creates different environment for communication between the team members. Climate, power, and then frequency, direction, modality, and content. The theory says, and we found that, like also in the interviews that we did, that is true, that if these are kind of like 7 points that like you can take care of and you can be aware of, so then your communication is going to be better. Of course, that doesn't mean that like it's all we need to do. No, but it's already some direction that managers and team members can start thinking about. So then you can get further with better communication, less conflict, and less problems in your team. So then the first one was the structure, and we asked people about like, how do you do your communication? So then if you have a co-located team, and then you ask like, how do you do communications between the dev and ops? They are like, we just talk. So there's not a big deal, right? So it's like, if you are co-located, you don't need to worry about what's the structure of the communication that you are going to do. Because it just happens, You are there, you are in the same room. If something pops up, the developer just go and talks to the operations guy, But if you have co-located teams, you have to think much more. So then you have to think of like, how am I going to do so then the communication is going to flow to these people, right? So then one of the things we noticed quite a lot was that people start working together without never met each other before. And then when we put teams to talk together and meet at least once, they always come afterwards and says like, wow, our communication is so much better now that we met, So then putting like this thing of like meeting each other at least once is quite important for the teams. And that really makes a difference on the communication. Then another thing that many of the participants talked about was to have joint chat rooms. So that means that like you have at least a way that like if something pops up, you just go there and fastly type the question or something that idea or some decision that you have made, So it's quite important that you start to think about structuring the way that you're going to talk between devs and ops. And then we also heard a lot about daily stand-ups or weekly meetings. I know that is not always feasible and not all the teams do daily stand-ups. So then you can do weekly meetings, but you have to think of like, okay, from time to time we have to have a venue where we can talk and where devs and ops are going to be discussing things that are happening on the development, Other teams, they have started to have tech talks, tech ops or showcases. There are different names for this. So then it's about like getting together and talk about specifically just about technology, and then everyone is in the same room. It's very important that you always think about like cross-functional. So then the cross-functional means like you have to have everyone from different expertise together in the same room and talking, So the second point is about climate. Climate it's difficult to define sometimes. Some people think that it's about like culture. Some people think that is about like how we bond together. So that is about like how devs and ops bond together, So then you have to think of like how they communicate, how they are supporting each other, how they are like trusting each other. So a lot of things that we heard on the interviews were like, as dev, the ops don't trust us to go to the server and do whatever we want, So then how this is going on, how the trust builds on the team and between developers and operations. Sometimes the ops guy said, it's hard because we never know if they're just like delivering something that's going to break, So then there is all this thing about trust. And then how do you build this climate that they trust each other and they support each other is very important for the communication. Otherwise, it doesn't flow. Then the third point is power. Power is a quite interesting topic, and it was someone said in the presentation before. And it's about like who makes the decision, So then, but then that's not something that like it cannot be that always the developers have the saying about decisions. If something comes up, then they have to know, the best teams are the ones that have shared leadership. That means that like the ones that are responsible or the ones that have the knowledge to take the decision, takes the decision. That doesn't mean that like it's going to be devs or ops. What happens when you have unbalanced power is that, for example, if the developers are always the ones that have the saying and always the ones that have the power, the operations start to not communicating well with the developers, you know? Because then it starts to be this like, sometimes there are fights of power, there are problems with like the developers just don't care anymore to say anything to the operations because it doesn't matter their opinion anyways, right? So, or if you have the operations in the other side, taking all the decisions all the time, they don't care about talking to the developers. Why bother, you know? It's just waste of time. So you have to, as like team members, you have to be thinking like, how is the power in our team? You know, how is the power balance in our team? Does everyone have a saying? Does everyone has a voice, independently of what is your role or what are your responsibilities? You know, of course, there are always things like, for example, if you are talking about system architecture, the developers probably have more of the knowledge to say what is going to be the final saying, right? But so then there are topics that you can have this unbalance, but you have to think of like, is it balanced or not overall, you know? And then come some other things that are a little bit easier to understand, like frequency, you know? So then if you have an open channel that everyone can come and communicate, or if it's just like one person or like one role that communicates to each other. It's like, for example, if you create silos that just the developers have access to some channels and they are talking about different things there, it's probably going to happen that decisions that the developers make, the operations have no idea what's going on. You know, so it's important that it's open, and it's important that it's always ready. You know, anytime that something pops up, you come in. So the way that I always think is like, if you were co-located, how would you do things? You know, so then always think of like, if you were together, you would be talking about this on the coffee machine, or you would be talking about this when you just stand up or hear anything. So that when you are co-located, for example, operations and developers, even when the developers are discussing something, you overhear something, you know, and the operations can pick up of these things. But if you are not co-located, then it's not so easy. So you always have to think, what do you need to share, you know? And meetings are always a necessary evil. So we always joke because we work with processes in Agile, and we always create new meetings, you know, and then these meetings start to come and come. But there are some things that are necessary, and it's necessary that the developers and operations talk and they are up to date with everything that is going on the project, so the communication can flow. So the fifth point is about direction. So if you start to see that like the operations are always quiet, nothing, they have never ask anything, they never start communication or anything, it's because something is unbalanced, you know. So then that means that like you can start to think that that's a bad smell, and then it doesn't really sound right, and then you have to think like, why is that going on? You know, so then you can start taking a look a little bit closer to see why it's that operations never ask anything to the developers. You know, it may be another problem with the power thing, or it may be that like there is something on the silos there that's not really working. You know, so we know that like, for example, when there are big launches or changes and so on, there is always much more flow between the developers asking the operations for help and so on. But in general, these have to be balanced somehow. Again, shared leadership and decision making is quite important. And always you have to think that ops needs to be engaged as much as the devs. What we heard a lot about from the ops part was that they said, like, you know, we try to listen. We don't really care about the chats and so on, but you try to listen. If there is something with my name, then I take action, you know. But they are not always super involved with the chat, but it's something that, like, they try to listen to the communication and act when needed, So that is something that is important to be done. But it's important that the ops is a bit more engaged also, and trying to see, for example, if there is a new feature or there is a new architecture that they are going to deliver, that the developers are going to deliver, take a look to see if there is anything that we need to be aware of, that the operations need to be aware of, or it's going to impact in something that you need to alert the developers about it. And then it comes to the modality. And then the modality is another thing that the developers, everyone commented a lot. And we are discussing if, like, is email still a thing, So then one other researcher that we talked to said, like, if you are communicating through email, that means that you are doomed, because it's not real communication, because it has to be instantaneous, especially when you talk about continuous delivery, continuous deployment, and so on. You cannot wait to see if the person is going to see the email tomorrow, So if you are still communicating through email, it's probably you have a problem. And then, like, these are the tools that, like, mostly everyone was mentioning, different ways of doing it. A lot are using the bots, and then bots is quite a big thing, and it seems to be something that is helping to flow the communication and to make people talk, because then sometimes the bots just, like, pop up with something that everyone looks, and then everyone starts to talk about it, and, like, at least it pops up to something that, like, someone is going to take a look or think about, or at least have the flags on, Yeah. And then it's about content. We say share everything. That means that, like, if you start as a developer thinking, like, should I share this with the operations guy? You probably should. And it's the same thing with the operations. Like, it's better to be safe than sorry. So it's better that you share things and that you talk about things and that you express what are your concerns, for example, as a developer. Share what are your concerns about the environment, if it's going to be something that you may think that may impact, So it's always important to exchange. So when we ask is, like, what do you share with the ops, or what do you share with the devs? These are the things that came up. Exchange of information, technology advices, requests, QA, information gathering, and then when there are critical issues, you have a different chat for, like, hotlines and things like that. But it's very important that each one starts to think, like, in my role, what do I need to share with the other roles, so then we all get together to the goal of delivering faster and better communicating with each other. So, what are the major lessons learned we got? We asked also everyone what were the major communication impediments and what were the major communication factors of success. And then these were the ones that came more up. So impediments came as, like, silos. So if you have, like, the developers in their own world and the operations in their own world, that is a major impediment for communication. It's not going to happen. Not sharing knowledge. So that is always something that we need to build with companies that we work with. That is about sharing, like, communities of practice, or communities that, like, you have one specific role talking together, or the two roles talking together, and things like that. So it's important. It's a kind of, like, it doesn't go directly to the work that you are doing, but it helps on the long term for, like, people sharing experiences, sharing technical knowledge, sharing technical expertise, and things like that. Another major communication impediment is about not speaking the same language. So if you have the developers that don't have much experience with what is going to happen when you deploy your system, and you have the operations that, like, have no idea how they develop that, it's hard to talk. So, like, no matter how much we say, like, okay, talk with each other, if I speak Portuguese because I'm Brazilian and you speak Norwegian, it's never going to happen. And not understanding each other's work, that was another point that everyone mentioned. That was, like, the problem is that then they don't know what it takes, So then they don't know what it takes for us to do this that they want us to do, So it's not only the operations coming and say, like, you need to get better performance, but what does that mean, So when you get into someone's shoes, then it's much better for you to kind of start thinking of like, okay, how can we balance this? And then less frustrations come with the communication, and then things flows much better. Too much control over the environment, that we put a little bit more on the heads of the operations guys, because they are the ones that usually get a little bit more protective about their environment, and they are afraid that things are going to break, right? So then one of the things that we heard quite a lot was like that after they started to put pagers on the developers, so then if something happens during the night and so on, the developer is the one that received the calls. Things went way better and way smoothly everywhere, because then things didn't break as much, So the developers were more cautious about that definition of done that Jan was talking about. The definition of done is like, it's in production, it is working, It's not, so then this concept of being working and it's not going to break, it gets much more internalized when you are the one that's going to receive the call at 2 a.m., or on the weekends, or when something happens. So that is one strategy some teams are starting to use. And not being clear and objective in the communication, that is also something that came up. So factors of success are usually the opposite, right? So then, but it's funny because the first thing that came was like, be clear and objective, So when you are going to talk with the other one that not always have the same background as you, not always have the same goals as you, and so on, you have to understand how you talk together, So if you have maybe to explain a little bit more of some things that for you are obvious, do it, because it's important that you are clear and you are objective with everyone. Work together. So there are some teams that are saying about like pairing for testing, pairing for deploying, pairing for doing different activities. That helps to like bring closeness between the two roles, and also to understand of like, okay, when like the ops could just be watching and then seeing like, okay, when you are deploying, this is what you're doing, or like when you are operating, this is what you're doing, or monitoring, or so on. Share autonomy and empower people. So commit to the job and do the tasks. And so all these things of like working together and coordinating tasks are important for success. And that is coming also very related to what I was saying about understanding what the other person goes through. That is the empathy towards each other. So understand what it takes to be in operations, understand what it is to be a developer, and get to know that person that you are working with, not only like on the work way, but like face-to-face meetings, and getting to know a little bit more of that person is going to help a lot with the communication, So then we come back to our topic. That was like, what is a fairy tale or horror story? You may say like, okay, she didn't really talk about fairy tale or horror stories. But when we were talking to people, that's what we asked them. We asked like, can you tell us what is your fairy tale and what is your horror stories about communication, And that is what we are also looking for to get more people to answer our interviews. That is like, can you tell us your fairy tale or your horror stories about communication? So then we can understand a little bit better how this can be done better. So if you could send me an email and then say like, okay, I would like to answer to the interview. It's just 40 minutes. It doesn't take much, but it helps a lot to improve research and improve our understanding on how to make communication better. Yeah, so that's it. Thank you. Questions? Does anyone have any question? No? Okay. Okay.
What's that? Oh, well. How do I swap these? That didn't help. There we go. There we go. All right, can you hear me? All right, so this talk is called Complaining is Not a Strategy, or How to Make Things Better Even If You're Not the Boss. To introduce myself, my name is Jason. I'm an engineering manager at PagerDuty. I work out of our Toronto office. PagerDuty is about half in Toronto, half in San Francisco from engineering perspective. And I come here today to talk to you about how you can make improvements in your own life. And so it's a bit of a self-help seminar, I guess. As you can see up there, I've been in the software business about 20 years. I spent 14 of that as a somewhat frustrated and angry developer before I got into management. I've always really cared about how to make things better and try to like understand, figure out how we can improve our processes and things like that. And it wasn't really until later on that I kind of figured out that I wasn't very good at it as an individual contributor. So this is kind of a sum up of a lot of lessons that I've had to learn the hard way, spending time being angry and getting over it. So, in the intervening years, I've been able to, learn from my mistakes and have some success. So I'd like to share that with you and explain like how, if the tables were turned and I was a manager and you were trying to, get me to help you make some change, some tactics you could use to do that. So I'm going to go out on a limb and make an assumption. The assumption is that there's maybe something about your job that if you had a magic wand or some time and autonomy, you'd make better. If that's not you and everything with your technology and culture is perfect, please propose an open space talk so I can find out more about where you work. If it is you, I'm going to further guess that you're dealing with one or more of the following kind of situations. Maybe you have a complicated code base. Maybe it's like the classic ball of mud. Maybe it's just a monolith and it's causing problems, but it's shiny somehow. It's a product. It's in the market. It has customers, but the engineering's kind of a mess. It was maybe originally hacked together by the founders of your company. They went, did a hack incubator, and suddenly there's a product, and you have to deal with it forever. Been down that road a couple of times. Maybe they didn't really know what they were doing. And then they hired some crummy engineers, and they made it worse. And then they hired some good engineers, and that's you, and now you're dealing with it. So, my heart goes out to you. I've been there. Over time, things grow and they get bug fixes and things bolted onto them, and it gets to the point where it's pretty hard to work with. So you've got an idea to make it easier, and you want to address it. You want to do some refactoring, adding some tests, whatever, break up your monolith, whatever it is. You've got some ideas. Maybe you've got some processes that kind of suck. They're not a good fit for your team. Maybe your processes are a little bit waterfall. Maybe it's this kind of agile. Poorly implemented. Maybe like a lot of companies, you didn't really start out with anything, and then you kind of have chaos-driven development as your process, and you need to formalize a little bit, and because it's starting to hurt too. So you've got ideas there where you can make it better. Maybe you've got communication problems, you've got silos, you're throwing stuff over the wall, you're throwing stuff at QA, you're throwing stuff into ops and get into production, and you want to stop. Maybe it's none of those things, it doesn't really matter. The point is, you want to make things better. But then, you have to convince somebody. And good, I hoped you guys watched that show. They maybe your direct manager, or product manager, or maybe it's the CEO. One way or the other, you need to make your case. So how do you do that? So I'm going to make the assumption that you're not really dealing with this guy, that the person you need to deal with has some degree of competence at their job, and that's important. And I'll be honest, the culture and process stuff can be really hard for an individual contributor to make sweeping changes to. That's something where you need really cross-organizational buy-in. And you can do that by sort of building up the political capital that you get from making positive changes in the areas where you do have influence. And that usually is the technology realm to start, and then you can kind of level up from there. So most of my examples here are in the sort of technology area, refactoring, that kind of thing. But I think the broader message, the overall message is applicable to whatever kind of change you want to take. All right, so lesson number 1, flex your empathy muscle. A lot of DevOps talk about empathy. When we talk about it, we're usually talking about our technical peers. We're talking about empathy between developers and operations people. So, things like putting developers on call. I'm on call right now. And having developers understand the kind of pain that ops goes through. And Agile talks about having empathy for the customer. But we don't often talk about empathy in terms of the business as a whole. There's a lot of other people that aren't technical working in a business. There's product owners. We've got engineering managers. We've got salespeople, support people. Everybody has their own job to do. And a lot of times we think that they're kind of clueless, non-technical dolts. But we ignore the fact that they're probably experts at whatever it is that they do. And they have objectives of their own to think about. They're probably not actually trying to get in your way. They don't wake up in the morning and think, how can I ruin Jason's plans today? Or, I'm sure glad we have a monolithic code base and I intend to keep it that way. They don't see the world the way you do. And that's important to think about when you're talking to them. They have different contexts, they have different goals, and they have different objectives. So if we're making a case to someone, it's important that we don't just talk about ourselves and what we want. We have to try to understand what our stakeholder has on their plate. Remember that whoever they are, they're answerable to someone else for some kind of deliverables. Even the CEO is answerable to a board of directors. And it's really important not to ignore that. I'll get into some of the anti-pattern versions of this near the end, but you have to be very, very careful, and you have to think win-win, which is from an old, I don't know, do you guys know the 7 Habits of Highly Effective People? It's an old book from when I was young, but that was literally one of them. It's trying to find a win-win scenario where we can give our stakeholders something that they want while we accomplish our objective, and that'll go a long way to convincing them. So, whatever it is your company does, it's almost a certainty that you're not selling your customers a nicely factored set of microservices. Your product is not a continuous delivery pipeline. Your customers don't care about how well you're following the Scrum Guide. Those things are all a means to an end, and that's, whatever it is that your business does. They're very important practices, but they're not what gets you paid, right? Someone buying your software or your software as a service is what gets you paid. So your stakeholder has to think in terms of business priorities, and that's their job. That's not your job, but you do have to think about those things too. If I was giving this talk to managers, I would be saying the other way around. Understand what makes your developers happy, but you're not managers, so I'm telling you, understand what makes your managers happy. I think it's important that it work both ways. I think that's sort of the magic recipe is if you get that two-way empathy going, where people are both thinking about how can we help each other out. For now, let's talk about how we can influence other people. Lost my place. I know it's not what gets you up in the morning to think about like business type things. you know, and you can say, well, I just want to leave the business to the business people, and that's fair, I get it. But I can promise you, the better that you understand their world, the more you can speak their language, the more effective you'll be at making positive changes. It's not easy. This is, like I said, it took me a long time of getting this wrong before I figured it out. But you know, win-win should be kind of the first place you look. So I'll give you a real example from my past. I was a new manager. I took over the business intelligence team. So we had internal stakeholders. We were producing, you know, reports for marketing and finance and that sort of thing on like how the business was doing. And the infrastructure that we inherited was probably about as messy as you can imagine. So it was like a script that someone wrote one day got thrown in there, and then you know we had some contractors come in and build some stuff on like a open source BI tool, and then a different contractor built something with a different BI tool that they liked, and it all kind of, everyone was kind of relying on it. A lot of other departments were relying on it to do their job, but it was really, really hard to work with from an engineering perspective. Like every change was one of those systems where you change one thing over here and then something over there breaks and you don't really know why. It was that kind of thing. Like you make a small thing, like you move a little decimal place over there and you're like, well, all of a sudden this report's wrong. Like what's going on? It was just a spaghetti mess. Yeah, but at the same time, the team was getting swamped with requests. Like we're getting requests all the time, like change this, change that, change that. And we, you know, people were going straight to the team members and asking for these things. So first thing I did was like, okay, all requests have to go to me. I'll prioritize, you know, shield the team from that kind of thrash. But we still couldn't really keep up. So I got another senior developer, put them on the team, and what they did, that person, they figured out you know, obviously could evaluate that things were not in great shape, but figured out a way to start making changes that were really positive. And this is actually a big lesson for me. What they did was they found the most frequently requested, the report that was getting the most change requests, not the one that took the longest to run, not the one that consumed the most disk space while it was running, just the one that they were getting the most requests for. So they asked for time to just, you know, focus on making that one better by kind of cleaning out some of the cruft and building it separate from the rest, rebuilding it separate from the rest of the existing system. So I said, okay, do that. I'll make some time for you. I'll fend off the hordes. And so they did that, and it actually made my life a lot easier because once that report was rebuilt in this new foundation, the changes got a lot easier, and it actually freed up a lot of time for the team. And what we were able to do was actually use that as a foundation and port the rest of the reports over to that system. So we ended up with a nice, newly factored system that replaced the old janky thing entirely over time. But the way that happened was, you know, kind of solving the biggest pain for me and for the business as a whole, really, first, rather than saying, let's just, you know, hand grenade the whole thing. Nobody gets reports for 6 months, and we'll build a new thing over here, which is, you know, that's an approach maybe younger me would have taken, but it's not a very effective one. So another thing you can do is spend some time educating and evangelizing. Whoever the stakeholder you might be imagining is that you need to convince, they're probably not here right now. They probably haven't seen a lot of these other talks. Maybe they are, but maybe their boss isn't. So it's important that we don't assume the person that we're trying to convince has all the same context we do, and will see the value of what we do immediately and enthusiastically. You know, we're probably going to need to do a little teaching, and that's an opportunity to also do some selling. That's where empathy and understanding your stakeholders' goals is going to help you the most. So while you're explaining what continuous delivery is or what containers are from a technical standpoint, you know, you can answer that question, what's in it for me, to the person that you're talking to. And so make sure that you address that too, and don't just focus on the shininess of the technology. Another example from my past, when continuous delivery was a new and novel concept, still mostly called continuous deployment. I got pretty excited about it. I went to a talk by Tim Fitz, who I think made up the term. And you know, I came to work and I was like, we should do continuous delivery or deployment. You know, every commit gets automatically deployed, and people went, holy crap, what are you talking about? That's crazy, right? You know, we were used to like QA cycles and code freezes, and you know, and this was like, you can't just like put something into source code control and have it go like, what are you, nuts? Like everything will break. And I was like, well, you're all stupid. You know, don't you pay attention? This is cool now. You should get with the times. And I realized, I think, you know, there's maybe a turning point for me too. I realized like they didn't see that talk, so they don't know what I'm talking about. So now it's on me to explain that to those people, especially the bosses and everybody else. But it was peers and everybody. Like everybody was like, "What? That's crazy." So you know, think about that too. Like that, it's easy to forget that not everybody has all the same context as you and hasn't spent the time sort of immersed in this kind of stuff as everybody else. So thinking big, starting small. When we do product development, we talk a lot about delivering small increments. You know, we talk about minimum viable, minimum testable, minimum lovable, and we always talk about those things when we're talking about products or product features, or even new products. When we take on improvement projects, we need to have that same mindset too. We can't take on a project with the scope of taking a 5 or 10-year-old monolithic app and turning it into microservices all at once. Like, we can't go from releasing once a quarter, as you know some people do, or every month, to releasing continuously all at once. The first milestone shouldn't be the promised land you want to get to. You can't. You have to take baby steps, incorporate whatever lessons you learn, take another baby step. It's boring, isn't it? I know it's not that exciting. But whatever it is you want to do, think about the smallest step you can do to get toward that. It'll make things better. It'll make it easier to get the buy-in that you need, and you'll probably learn from it anyway. So you can build trust. You can build capital and continue to that you can use to continue the initiative. This one's really important. Really understand what you're trying to do. Any potential improvement should have a clear testable hypothesis behind it. If you want to release more often, I think that's great, but you should understand why. It's not because releasing is fun. You want to do it to probably, I'm guessing, reduce production bugs. So is the number of production bugs you have now somewhere easily accessible so you can watch it go down? Can you see how your improvements are impacting it? If you want to get all your components into containers, what's the tangible benefit of that to your organization? Fewer configuration-related bugs, fewer bugs in general, faster deploy times, lower infrastructure costs, all those things are things that you can theoretically get from using containers. Which one of those is the biggest pain point for you? Can you articulate that and can you measure it? Do you actually have any of those problems? Are they the biggest problems versus something else that you could spend your time on? Those things are really important to know. And once you have that hypothesis and you know what number you're trying to move, take the smallest step you can, as I said before, that'll impact that number. You know, containerize a single service, continuously deploy one small code base if you have more than one. It can be tempting to take other people's metrics or say it's common sense to justify these kinds of initiatives. You can read articles and go to talks and hear other people talk about how this or that change made a big impact on the organization, and we can imagine a similar impact on our org. But you have to be careful there. It's really easy to let our own enthusiasm for technology bias our thinking, and justify it so we can justify it to ourselves that we're doing the right thing, but really we're just doing something cool. And it's important to build the discipline to be as rational as possible, and so metrics help us do that. So building the understanding where your impact is and measuring it kind of helps you get away from the anti-pattern where you're biasing yourself. When you're talking about things, use the language of experimentation. So be clear to everyone that you're trying these things out as an experiment. Don't promise things that you're not sure you can actually deliver on. So you're going to try something out. Be clear that it's a hypothesis. These are the outcomes we're trying to get. Not everything works out. So I hope you all know that by now. You can screw up the implementation. You can get it perfectly right and find out that it didn't have the impact you expected. So that's why we start small and why we use language of experimentation. Big bang releases are a bad idea in product development, and they're a bad idea for technical improvements too. So don't promise revolution, even if you're sure you can deliver. Ask for trust and help. You can't make everybody happy, and you can't address every fear. People will find all kinds of reasons to tell you why what you're trying to do is a bad idea. And some of those people are, maybe a little more out to lunch than others. And some people just resist change no matter what. I always find that interesting. People in software, it's a human tendency to fear change and resist change. But we work in an industry that's very change-oriented. Change happens all the time. But there still are people that sort of default to hold on. No, not sure why, but they exist, and you have to deal with them. So, explicitly asking people for trust helps a lot. Assure them that you've heard their fears. Don't be like, whatever, buddy, because that doesn't help. That doesn't help them endear yourself to them. Assure them that you've heard your fears, even if you think they're crazy. Keep that to yourself. And that you're open to the possibility that you're right and that you're wrong, but ask them to trust you and give it a try. Again, a lot of this stuff is hard to do. Building a business case for the change you want can make a really daunting task. You don't have to do it alone. Ask for help. If your manager has a clue, this can be a good opportunity to work with them. Ask them to help you build a business case for it. They probably understand the business fairly well, hopefully, and maybe the two of you working together can come up with a more easy to sell package. Ask your peers, ask people who've done it before. You don't have to go it alone. Another thing that I had to learn the hard way, I would come up with a proposal, and I'd be like, my proposal, and people would go, you forgot this and you didn't think about that, and I would be like, oh, I did a terrible job. And so you don't have to get it right the first time. So spending more time by yourself, kind of polishing it, doesn't really help. Get it out, socialize it, talk to other people. They'll help you find things you missed. So getting help is really important. The more people that look at a plan, usually the better the plan gets. So those are some things you can do. That will help you out. So now I also have the what not to do portion. So first of all, don't be this guy. Running around, do you have these guys in Norway? Think that the world's about to end? Running around saying we're all going to die is fun and gratifying. It's probably not true, and ultimately nobody takes you seriously. But if assuming this guy is real and not an actor or something, one thing to remember is he really thinks that the world's going to end. He believes it truly in his heart, and you may find yourself in that situation someday from your technical perspective. If you're neck deep in a technical problem and it seems insurmountable, and it's like the third time that month that you're in that situation, you'd be really tempted to just say like, flip the table, declare bankruptcy on technical debt, flush the whole code base down the toilet and start over. It's very tempting. And you may truly feel like that's the right thing to do, but recognize that is that's often a very emotional response and not necessarily a rational one. It almost isn't ever the right thing to do. Once again, I've done it. I've regretted it. And keep in mind too that the business person that you're talking to, if you're going to come and tell the CEO of your company that you need to flush your code base down the toilet, that's how their company exists because of that product, right? Like it's out there. If nobody's buying it, sure, flush it, whatever. But assuming that you have a job, probably somebody's paying for this product somewhere. So it'll be hard to make them believe that we should just like, that was a bad idea, let's start over. A lot of people have written about why giant ground-up rewrites are a bad idea, so I hope I'm not telling you anything that's news. But, you know, nevertheless, I've done it a couple of times early on when I was a baby. You know, I've had several developers come and tell me that a code base is unsalvageable, you know, needs to be rewritten. There's nothing in there worth keeping. You know, I'm pretty convinced at this point that's never the right solution. So not a great place to start if you want to make change. This one is a little more controversial, but really watch out for the "this will make everyone more productive when we're finished" argument. If someone comes and tells me we should, you know, redo all our front-end code in whatever new JavaScript framework came out yesterday, you know, or port all our back-end services to Elixir and Phoenix because, you know, it's so much faster than Ruby and it's so much easier to work with and developers will be more productive, I'm going to be like, I don't know. It's very enticing, right? It's an enticing argument. You hear about a new framework, you go home and you code a to-do list app or something in it, and you're like, wow, look at it, it's like beautiful. You know, I can reason about it, it all fits in my head, and everything is nice and neat and tidy, and I wish my work code base looked like that. And, you know, it's easy to sort of falsely attribute the neat and tidy nature of that new code to the language or the framework that you used, when really it's just actually small. And it doesn't have customers and users and the things that make code bases messy over time. You know, it's very hard to say, well, first of all, it's very hard to measure developer productivity in the first place. So if you're trying to do something that's measurable and prove that you've made things better, you're already kind of behind the game because it's actually really hard to do. It almost never plays out this way because of reality, because you have customers and users, and unless it is like actually like the story I told about the BI framework, that wasn't the justification for doing it with developer productivity. It was more like you know, trying to make it work better. We got developer productivity out of it, but that wasn't where we started. One more, be careful about the words you use when you're describing the systems that you have to work with. Remember that it didn't spring into existence all by itself. It was written by human beings who did the best job that they could with the information and knowledge they had at the time. In fact, it may have been written by the very person that you're trying to convince that it isn't very good. That means you should be a little extra careful about the words you use. It can be very hard to get past, if I'm listening to someone, it can be very hard to get past their bluster if they're just like, this is an abomination. It should never have existed. It's very hard to get to the actual, you know, substance of their argument if they're using language like that. So, you know, turn the vitriol knob down, all the way down. Avoid characterizing the code at all if you can. Talk about it in very rational terms. It doesn't have unit tests. It doesn't perform very well. Here's a graph. Those kinds of things are much more convincing than I hate it and it makes me feel bad. That may be true. It's just not a very good argument. And it gives the listener a reason to stop listening to you. If you're using words like that, it's easy to, you know, someone who's busy and has 47,000 things on their to-do list, and you come to them and say, you know, this code is an affront to Jesus. Then they're going to be like, okay, yeah, that's nice. I'm going to go to my meeting now. So it'll ensure your ideas really get nowhere. Lastly, the process of making software, it's imperfect. It's always interesting to come to talks, and especially when people talk about, look at the exciting thing we did at my job, and you're like, oh, I wish my job's stuff looked like that. And you know, probably their stuff really doesn't look like that. They've polished it and shown you a nice picture. And because really, things are never perfect. And even if they are, that only lasts about 3 seconds because the world is constantly changing. People's tastes and norms are always evolving. We always have better information today than we did yesterday. And so when we strive to make things better, we should always think about how we can make things better for everyone around us, and not just for ourselves. If I can leave you with a parting challenge, I would say I would like everyone to go learn about some aspect of your company's business that you don't know something much about. So something maybe in the non-technical realm. See if you can shadow your manager for a day, see what their day is like, hang out with the marketing people, see what they deal with, hang out with the salespeople if you have those, and get to know what their job is like. If you can, invite them to do the same with you. It will make you a better, more well-rounded technologist, and it'll make it easier for you to bring about the kind of change that you care about. So that is all. I have some image credits there for some of my backgrounds, and if you want to talk about this more, I'll be around. I don't know, that's going to go on the floor.
Is it on? All right, cool. So my name is Chris Beltart. I've been running the Ignites at different DevOps days for the past 7 years. And for those who've never seen an Ignite, it's kind of a fun format. These guys have about 5 minutes. They prepare 20 slides. They don't get to forward the slides. They're gonna auto-advance every 15 seconds. And well, there's a challenge for them because they have to bring out their message in 5 minutes and keep in sync with the slides changing. The fun parts about this is that sometimes it's topics that don't really fit into the exact conference, but it's only 5 minutes. So if you really don't like the speaker, you have 5 minutes to check your mail and then be attention again. So I've lined them up. I hope they're actually in the right order. So I'm kind of assuming that you are Anton. So first up, Anton.
So hello, everybody. That's really going to be a challenge to keep it in 5 minutes because topic itself is very, very big. I figured out this only when I started creating it. I didn't have a clue about this before. So first of all, who am I? My name is Anton Babenko, and I work for the last 10 years as web developer, tech lead, and CTO. And I really like to work with Amazon Web Services and DevOps. I actively participate in open source. So what this talk is going to be about is not about, I'm not going to mention, or at least try to not mention, any specific tools' names. I'm going to answer how to identify red flags and where to pay attention. So to begin with, let's think about what's your perspective in using any of these tools. What do you want to achieve? Like, what goals do you want to have specific tool to help you reach? So that's question number one, which you have to take into account. Second is skills which are currently available in your team, company, and whether you're willing to hire someone with expertise or not. So what budget you have. As we all know, we probably can count tools in hundreds. Different suppliers, different brands, all of them have multiple options for multiple things. So I was trying to think about this as separation by team size and number of tools. Not going to go in specific tools. So when we have few tools, it's usually a small learning curve, and my only solution to that is using open source. With large teams, it's usually using few tools, you get over-engineered solution where people say, oh yeah, I can do everything in Ansible. Of course, but there are other tools. So when you have many tools, you have to think about how to orchestrate them and automate how one tool can call another one. So it's usually solved or sometimes solved using SaaS. In large teams with many tools, things are getting much more complicated usually, and that's why you have to facilitate knowledge sharing and really avoid silos. And please don't try to think about, hey, this is not my problem, because this is operation problem now. So tools teams with many tools always require good culture, so you have to be shareable. And I've been to several companies where I met people who was always willing to make another tool to deploy something. So yes, this is tool number 5, but it will solve my needs. So go externally and think about expenses which are going to be caused by this innovation. So in many cases, tool already already created. But if not, then you will have significant cost on maintenance, development, and so on. So that's why I'm actively using open source tools, because I don't have to create it myself, even if I can, or team can. So chances to fail in different companies is usually big. But tools can fail, but company is not going to fail. For example, if community size is big, then most likely someone will maintain. If Stack Overflow has a lot of questions and a lot of people talking about it, then most likely it's a good sign. And last is development activity. How many issues open, pull requests submitted, who is actually submitting pull requests, who is actually writing code. Is it just employees or is it any random people? So it's very important. Also think about how it will feed to your current ecosystem, like which technologies are used, which programming languages are used. If you are, let's say, PHP shop, it will be challenged for you to convince people, hey, now we have to maintain and write something in Java. And extendability is amount of free options which you can, let's say, download as plugin modules, or how fresh the community is. As previously been said by Jason, start small, evaluate, and then iterate. This is one of slogan which I like to follow daily. If I try to find something, I usually explore communities, and then I talk about it. Thanks.
Yeah. Okay. Hi, I'm Kjetil, and this is my first Ignite talk. It's a really cool format. I'm not allowed to use speaker notes. Now we wait for the next slide. So, welcome to this inspirational talk on how to kill DevOps. By the time we're done here, you will be equipped with some surefire ways of shooting down any DevOps effort. Well, killing DevOps is not really a great career move, but even so, it seems like some public sector organizations really work hard on doing just that. I think it must be in order to keep employment up when the economy is down or something like that. Before I move on, let me just say that the inspiration for this talk is from actual experience in the field. To protect the innocent and the guilty, I will name no names, but I am so glad we take a video of this because I'm going to send it to them. Let's get to it. The key to killing DevOps is to hit it at its core. Aim for the vital organs, use expanding bullets, and let me present my top 5 expanding bullets. Bullet number 1. Specialize every team and separate them. Put developers, testers, and ops people in different departments. Put the different departments on different floors or in different buildings. And if you have the power to do so, put them in different countries with different cultures and different languages. That way, and also, remember to use crappy video conferencing and Remedy. The way to screw up communication like this, and you will be sure that DevOps will never, ever succeed. Create tons of specialized roles and make sure there's a role for everyone and no overlap. This way, things will have to wait when someone becomes a bottleneck. And imagine when the bottleneck goes on vacation, nothing will hit production for weeks. Bullet number 2. Meticulously organize work. Make detailed process descriptions of everything, and do this because this will make quality consistent. The fact that quality becomes consistently bad and slow is really awesome. This way, DevOps will never thrive. Also, make sure that process descriptions are damned hard to change. In fact, do not describe the process improvement process. If you skip the process improvement process entirely, even if people want to change things for the better, they don't know how to. Bullet number 3. This is about making automation efforts hard or impossible. I suggest use Windows on all your servers except some. And a heterogeneous server farm is awesome. This even applies if you're running virtualized servers. And make sure you name your servers after pets. We love pets, don't we? If you treat your servers like cattle, well, we are not very nice. So, poor animals, poor servers, treat them like pets. Another foolproof trick is this. Make sure no network setup is automated. And make sure the network team is really understaffed. It will drive people nuts waiting for firewall openings. Yay! Bullet number 4. Create mistrust. This is actually my best advice. Gatekeeper roles that check our work is really awesome for this, especially when they don't have any idea on how to evaluate the deliverables we hand over. Actually, it's the best thing when they don't have a clue. It will frustrate people who care so much they will eventually resign. And getting people who care to leave your organization really, really works great to kill DevOps. But don't worry, if you follow all the other things I say, this will happen all by itself. Bullet number 5, fuck up feedback loops. Think of how one can shorten and amplify feedback loops and do the opposite. This is the best thing about slow feedback loops is that people get used to them. After some time of messing with the feedback loops, people won't even notice the consequences of their actions, and your work is done. No feedback, no DevOps. So that just about concludes this inspirational talk on how to kill DevOps. Remember to specialize and separate, create detailed and rigid process descriptions, make automation hard or impossible, create widespread mistrust, and fuck up the feedback loops. If you happen to work in the public sector, please talk to me afterwards. I am more than willing to come to your organization and give this inspirational talk. On a good day, I might even try to come up with strategies on how to counter all this nonsense. But that is really hard work and not as much fun.
Yep. Good luck. Thanks. Hi, my name is Anders. I've been working with DevOps in large organizations for the last 2 or 3 years. Coming from lean and agile or some bastardization of agile for the last 10 years. So DevOps is sort of like the natural next step for me. First of all, I just want to point out that, of course, this is a journey. It's not something you buy. It's not something you arrive at. It's about becoming more agile. It's about getting better at automation, continuous delivery. It's about changing your architecture and changing the people and the organization that you're in. And of course, automation is key. There's a lot of cool tools out there, but more than anything, this is actually about changing how you communicate and how your organization operates. Because one of the major things that I think DevOps is about is how you think about trust and responsibility in your organization. Many classical organizations that try to move to DevOps with command and control will basically fail because they're replacing trust with command. So you need to enable your organization and your development teams to actually take responsibility. You need to kill the handovers, minimize external overrides from architecture and security, and you need to remove the notion of the others, because we can always blame the others. And most of all, people actually feel responsible. This is not just mechanics or a way organization works. You actually need to think about people's feelings and how you enable them to feel responsible. And of course, this is a long journey. It's something you practice over and over again, and you need to keep your eye on the horizon, knowing what your goal is, because you will fail a lot of times before getting closer to the goal. And of course, speed kills. So if you want to be a fast-moving organization, you need to practice and you need to build quality in from the start, and you need people to actually feel responsible for what they're making to actually enable them building quality. I'll talk a little bit about some common patterns I've seen. These are mostly valid for large organizations, but they're pretty common anyway. The first pattern that I'm going to talk about is where you suddenly figure out that we're going to do DevOps, so collaboration, let's do that. That's a new thing. Let's get developers and operations together and let them collaborate. Well, it's better than not collaborating, but you still have the separation between developers and operations. So you need to figure out a way to eliminate them versus us, to eliminate the separation. And the easy 5-minute version of this is, of course, put operations into the same team as the developers and let them take responsibility from development into production. So you need to change how responsibility is defined in your organization, and you need to redefine where trust is defined. And that might even mean changing your architecture and changing your systems. Nobody said this was easy. Pattern number 2, DevOps is a role. You see a lot of companies, they try to hire someone into the DevOps role. And even though you put the DevOps in the team with the developers, it's still a role. It's the DevOps guy. It's his responsibility. I'll make this fantastic functionality, and our DevOps guy will come in 3 or 4 days later and fix this. But the thing is that taking responsibility for your software that you're creating and putting into production actually means understanding the larger picture. You need to understand what happens in production when you make the shitty decision as a developer. And you delay all of the decisions because your DevOps guy will come in 3 or 4 days later and actually make something you don't really understand. All right, the third pattern, selective automation. I see a lot of organizations try to do DevOps, come in, let's automate everything. But we're not going to automate this thing because we're not going to do that as often. It's not worth it. We're not going to get any problems with it. But the thing is that automation is what actually builds predictability and quality into your software. So if you start to get selective about this, you will trip up, and you don't really know when you will trip up. And that, again, will challenge your feedback loops, and it will actually trip you up when you least know it. So you need to actually invest in automation all over and not do selective automation. Basically, trust and responsibility is at the essence of DevOps, I think, and it is the key to actually moving fast and enabling your organization to take responsibility and feel responsible for the software that they're creating. That's it. That's 5 minutes. Thank you. Just get in touch if there's anything I can talk to you about.